Question 5, part 1. The dissociation of water is shown below. So we've got there the equation for dissociation, and we're told at 60 degrees the Kw value is 9.311 times 10 to the minus 14, whereas at 25 degrees we know it's 1 times 10 to the minus 14. Explain whether the dissociation of water is an exothermic or endothermic process. Now this is quite a tricky question, involving you having to link your knowledge of equilibrium to this concept of dissociation. So you've got to take the facts for what we can see. So we can see that the Kw value at the higher temperature is bigger than it is at the lower temperature. Now remember, Kw is just another expression of the way really referring to an equilibrium constant, and the value of the size of the equilibrium constant is an indication of the position of equilibrium. So if Kw is higher at the increased temperature, that must indicate that equilibrium is being pushed to the right-hand side. So if we've increased the temperature, and that's caused a shift in equilibrium to the right-hand side, that must mean the dissociation of water is endothermic. If you remember, you learned in your first year that exothermic reactions in the forward direction, increasing temperature shifts equilibrium left, and decreasing it shifts right, and vice versa for endothermic. So in this case, increase in temperature has increased Kw, that has therefore pushed equilibrium further to the right-hand side, indicating there's been more dissociation. So therefore, the dissociation has got to be endothermic. And that's where your marks come from. So you simply say that the reaction for dissociation of water is endothermic because the equilibrium has been shifted to the right-hand side.